to all. I'm Dr.A.Francia Shalini, Assistant Professor, PG and Research Department of Mathematics, Nirmala College for Women, Coimbatore. In this module, we are going to see about the basics of mappings.
First, what is the definition of a relation? Generally, a relation gives the relationship between an input and output. Here, if A is a set A and A is mapped onto a set B, and we define the relation R is said to be the Cartesian product of the sets A and B. R is said to be the subset of A, A Cartesian product B. The next definition is the definition of a function. A is said to be the domain and A is mapped on to B, which is the codomain, and here the relation R is a mapping from A to B, and we define it as and we name it as a function. Now the next one is the definition for equivalence relation. Equivalence relation satisfies three conditions. One is the reflexive. Reflexive condition states that if A is conjugate to A in a set A, then the relation is said to be reflexive in A. And symmetric, if A is conjugate to B and B is conjugate to A in a set A, then the relation is said to be symmetric in A. Transitive, if A is conjugate to B and B is conjugate to C, then A is conjugate to C in the set A, then the relation is said to be transitive in A. So a relation which satisfies all the three conditions, that is reflexive, symmetric and transitive, is said to be an equivalence relation. So the other names of a function, as we have learned about function earlier, the other names which we use for a function are, functions are also called as mappings, operators and transformations. So the transformation. What is a transformation? Transformation is from a set S is mapped on to a set S, and we define it with the function f, and we call this as a transformation. You're going to see the next type of function, one-to-one function. A function is one-to-one if no two elements in the domain of f correspond to the same element in the range of f. That is, here we see the set A has elements A, B and C, and the set B has elements 1, 2 and 3. Here A is mapped onto 3, B is mapped onto 1 and C is mapped onto 2. It's clearly seen that no two elements in the domain which has elements A, B, C correspond to the same element in the range, that is 1, 2 and 3. Such a function is said to be one-to-one function or a one-to-one mapping, and it is also called as an injective mapping. The next one is an onto mapping. Onto mapping is if for every element of B there exists a pre-image, then we say that the mapping is an onto mapping. Here we see the set A has elements A1, A2, A3 and the set B has elements B1 and B2. Here elements A1 and A2 are mapped on to B1 and A3 is mapped on to B2. That is, for every element in B, the elements in B are B1 and B2, and both the elements have pre-images A1, A2 and A3, and this mapping is called as an onto mapping, and it has another name which we say it as surjective mapping. The next one is an one-to-one and an onto mapping. If the function is both one-to-one and onto, we call it as a bijective mapping. The next function is a many-to-one function. A many-to-one function associates two or more values of A to a single element of B. Now here we see in the example given, that is the set A has elements A1, A2, A3 and A4, and the set B has elements 1, 2, 3, 4, 5 and 6. Here a many-to function, that two or more values of A is mapped onto a single element. So A1 and A2 are two functions. It is mapped onto a single element 1. Likewise A3 is mapped onto 3 and A4 is mapped onto 4, and we say it as a many-to-one function. The next type of function is an inverse function. We say it as if R is a relation from A to B, R inverse goes from B to A. So it inverts the elements, and those we say it as an inverse function. By the example given here, f is a function from the set A to set B. That is, the set A has elements A, B, C, and B has elements 1, 2 and 3. A is mapped onto 3, B is mapped onto 1, and C is mapped onto 2. F inverse is the relation between from B to A, and we say it as 1 is mapped onto B, 2 to 3, and the element 3 to A. So this inverts the element, and so we call it as an inverse function. The next function is a constant function. So a function whose image has all the values in A is mapped onto a single image in B, then we say it as a constant function. Here the set A has elements x, y, u, v, l. In B it has elements 3, 5, 7, 8, 10, 15. So all the elements of A are mapped onto a single element in B, and we call it as a constant function. And then finally we name another function which is called as an identity function, and here the set A and has the same elements as set A is mapped on as when set A has 1, 2, 3, 4, 5, it is mapped on to the same element in the set A, which is 1, 2, 3, 4 and 5, and we call it as an identity function.
Hope you had a better understanding about the mappings. Meet you all in another module shortly. Happy learning. Thank you.